Hello, so nice quick starter today. On the screen is the word stems, and it's not meant to be the word stems as in the part of the flower. Instead, the S, the T, the E, the M and the S each stand for something else, all to do with how our body stops pathogens entering our bodies. Pause the video while you try and work out what each of the letters means. And here are the answers. We've got skin, tears, mucus, stomach acid. That was a bit cheeky because it's really two words. And then the one I think will be the hardest to have got is E for earwax. Well done if you got them right. I'm going to start off with a quick reminder or recap. So when pathogens get past these defences, we have to rely on our immune system. Our immune system consists of two types of white blood cell that you need to know about. So we've got lymphocytes and phagocytes. Lymphocytes are the ones that make antibodies against pathogens, and phagocytes are the ones that engulf and destroy pathogens. We've heard that before, but slightly new term just that we need to add in is that lymphocytes are really specific because those antibodies only bind to one specific antigen on one specific pathogen. It makes this response really specific. Hence, lymphocytes are involved in the specific immune system, which we talked about in a previous lesson. And then phagocytes are not specific, so they will engulf and destroy any pathogen that it comes across. If you have a look at this diagram, it shows the stages of phagocytosis. This is the process that phagocytes do in order to engulf and destroy pathogens. You don't need to be able to use that word just yet though. But in this diagram, you can see there's a phagocyte and a bacterium. The phagocyte has bound to the bacterium. And then the membrane of the phagocyte sort of extends itself until eventually it closes together and makes a little bubble, which is called a vesicle, that the bacteria is in, and then that bacteria gets broken down or degraded. We are now ready for our title, which is monoclonal antibodies. And the aim of today, and actually our next lesson as well, is to describe what they are and how they're produced, explain their uses in medicine, and then evaluate, so look at some advantages and disadvantages of monoclonal antibodies. Because we've used lots of new terminology recently, I just want to do a task where we match up some words to their definitions, so please complete these in your book. We need to be able to define antibodies, lymphocyte, phagocyte, monoclonal and polyclonal. So antibodies, lymphocyte, phagocyte, I think you'll be able to do quite easily. And then the new ones that we need for today, monoclonal and polyclonal. So pause the video and give them a go. And here are the answers. So antibodies are protein molecules that bind to a specific antigen. Now we've got that word specific. We've got lymphocytes, which are white blood cells that produce antibodies. Note again that we've got that word specific. And then phagocytes are white blood cells that engulf bacteria or pathogens. These are not specific. And then monoclonal antibodies are where one specific lymphocyte makes one type of antibody. You can kind of guess that from mono, meaning one, and then polyclonal, where several lymphocytes are activated and each makes a different antibody, producing a mixture of antibodies. We're not really interested in those today though, so the focus is on monoclonal, just one specific lymphocyte making one type of antibody. So following on from that definition, what actually are monoclonal antibodies? They are produced from a single B lymphocyte. So when we're talking about monoclonal antibodies, you just have to add a capital B in front of the word lymphocyte. Monoclonal antibodies are all identical, therefore they all target only one specific antigen. And this makes them really useful in medicine because they only target a specific cell or a specific chemical in the body, which is actually really clever. So, for example, in cancer treatment, traditional cancer treatments include chemotherapy or radiotherapy, and these don't just target cancer cells but also healthy cells as well, which is why they cause quite nasty side effects. But if you could attach a drug to a specific antibody, then it would only target the cancer cells. So lots of monoclonal antibodies are actually in clinical trials right now. Now we know what monoclonal antibodies are, we need to know how they're produced. And as I'm writing this out now, I've just noticed that it's actually really long to write, and you can simplify monoclonal antibodies to MABs, so the M, the A and the B for monoclonal antibodies. Just have a look at this diagram for a second, pause the video and try and understand it for yourself, then I'll break it down into steps. Please just watch and listen to begin with. I'm going to go through this in lots of detailed steps and then I'll show you a summarised version at the end, but you need the detail in order to understand the summary, so bear with me. We begin with a mouse being injected with an antigen, which if you think about it is just the immunisation or the vaccination process, which we've already learned about. So that's what the next couple of steps are going to be summarising. Step 2 is where the mouse's lymphocyte with the correctly shaped antibodies will be activated and start dividing. Then some of these lymphocytes will release antibodies specific to that antigen. So we've learned that story before. New detail is that once lymphocytes kind of decide that they're going to be the ones that release the antibodies, they are no longer able to make copies of themselves. They can't grow and divide anymore. So these B lymphocytes are isolated or taken from the mouse to be used. If you look at the diagram, the antibody forming cells are these lymphocytes. Next, some tumour cells are isolated. So from a tumour, from a cancerous tumour, some cells are taken. And these tumour cells can grow and divide rapidly. Now we have isolated some lymphocytes and we have isolated some tumour cells. We fuse these two together to form what are called hybridoma cells. Now these have the characteristics of both lymphocytes and tumour cells. So they can produce antibodies specific to one antigen, the one that the mouse was injected with initially, but they also have the ability to grow and divide rapidly. Now these hybridoma cells have been created, they get screened, they just get checked to make sure they're producing the antibody that we want them to. So checking that that antibody is specific to the antigen which we first injected the mouse with. Then antibody producing hybridomas are cloned, that's what it says in the diagram. So the hybridoma cells are just allowed to grow and divide, and they grow and divide by mitosis. The outcome of mitosis are identical daughter cells, and as they're identical, they are essentially clones. And then monoclonal antibodies produced by these hybridomas are isolated, ready to be used. So there's all the long-winded detail, and now I'm going to give you a nice answer summarised into 3 steps. So first we have our mouse injected with an antigen, and B lymphocytes produce specific antibodies against it. They are isolated. Then B lymphocytes are fused with tumour cells producing hybridomas. Hybridomas grow and divide and produce monoclonal antibodies which are isolated for use. Simple as that. Okay, watching and listening over, now it's your turn. So I'd like you to use this video to produce a step-by-step guide for producing monoclonal antibodies. I want you to describe and explain in quite good detail to somebody else how they would produce monoclonal antibodies. It would be great to include diagrams to help a person who is using your guide to actually visualise the process. They'd just be quick sketches though, nothing fancy. And then you've got 2 options. So if you're not feeling particularly confident with this, I'd like you to just use the back of your book or a scrap piece of paper and try and draw out the process as many times as you need to until you can do it by memory. So just nice and quickly, again and again and again. You could abbreviate words as long as you know what those abbreviations stand for, until you can write out the whole thing without having to check back at the video or check back on your notes. If you're feeling more confident, then I want you to try the worksheet. It is quite tricky, but when you're done, ask me for the mark scheme, and as always, tag me in a Teams post if you have any questions.